Hi all, this is Mrs. Pettit, and I'm here with lots of good news today. First, we're starting a new quarter, which is hard to believe. We're starting a new unit, which is always good to have a change of pace. And everything we're doing today will be review. The first thing we'll do in our new unit on radicals is a review of simplifying radicals. Remember, when we simplify radicals, we always want to find the smallest possible number to leave under the radical. In order to do that, we need to look for perfect square factors. To make things a little bit easier moving forward, let's find the first 15 perfect squares. Remember, to find a perfect square, you just take a number and square it. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. So if we want to simplify the square root of 200, we're looking for the largest perfect square factor of 200 and what's left over. So we can simplify the square root of 200 into the square root of 100 and the square root of 2. But the square root of 100 is 10, and then we just leave the square root of 2. To simplify the square root of 108, again, we're looking for perfect square factors of 108 and what's left over. We can simplify the square root of 108 into the square root of 36 and the square root of 3. The square root of 36 is 6, and we just leave the square root of 3. If there's a number out front of the radical, that's fine. We just leave it until we have the radical simplified, and then we come back and multiply it in. So we'll leave the negative 3/2. We can simplify the square root of 128 into the square root of 64 and the square root of 2. The square root of 64 is 8, and we leave the square root of 2. Now we can multiply what's sitting out front. So negative 3 times 8 is negative 24 divided by 2, and leave the square root of 2. And negative 24 divided by 2 is negative 12, and we leave the square root of 2. When multiplying radicals, we have a couple of options. You can see in the first example that everything is under a radical. If that's the case, then we're going to multiply everything under the radical and then simplify. However, if what's under the radical can be simplified, sometimes we'll want to simplify first and then multiply. And then it'll make it look like the second example, where if there are numbers outside of the radical, then we multiply everything outside and we multiply everything inside, and then we simplify. So if we take a look at example number 4, you'll notice that the square root of 11 has no perfect square factors in it, so we can just leave that. But the square root of 44 can be broken down into the square root of 4 and the square root of 11. The square root of 4 is 2, so I'm going to bring that out front. And then I'll have still the square root of 11 times the square root of 11, which is 2 times the square root of 121. The square root of 121, though, is 11, and 2 times 11 is 22. In example number 5, we're going to multiply what's outside and what's inside. So what's outside is 5 times 2, so that's 10. What's inside is 3 times 3, so we'll be left with rad 9. The square root of 9 is 3, and 10 times 3 is 30. For a problem like number 6, we'll want to take those mixed numbers and turn them into improper fractions so we can then multiply and then simplify what's under the radicals. So if you remember, to turn a mixed number into an improper fraction, you're going to multiply and then add. So 7 times 3 is 21, plus 3 is 24. So the first radical is going to become 24 over 7. And the second radical, remember, you multiply and then add. So the second radical will become 3 times 2 is 6, plus 1 is 7 over 3. And then we can put them together under one radical. So we have 24 over 7 times 7 over 3. And if we start to simplify first, you can see the 7's go, and 3 goes into 24 8 times, and into 3 once. So we're left with just the square root of 8, which can be broken down into the square root of 4 and the square root of 2, which ultimately leaves us with 2 rad 2. In order to divide radicals, the biggest thing we have to remember is that no radicals can be left in the denominator. In order to get the radicals out of the denominator, we need to multiply by a convenient form of 1. The way we do that is simply to multiply both the numerator and the denominator by whatever radical is in the denominator. So if we take a look at example number 7, if we multiply both the numerator and the denominator by the square root of 2, which is essentially just 1, we haven't changed the problem. So in the numerator, we have 4 times the square root of 2, and in the denominator, we have the square root of 2 times the square root of 2, which is the square root of 2 squared, which is just 2. And then when we simplify, we end up with 2 square root of 2. For number 8, we have a rad 5 in the denominator, so we'll multiply both the numerator and the denominator by rad 5, right? Our convenient form of 1. And in the numerator, when I keep the 15 on the outside and multiply 2 times 5 on the inside, I have rad 10. And again, in the denominator, if I multiply rad 5 by rad 5, that's essentially rad 5 squared, which is just 5. And again, when I simplify, I'll have 3 rad 10. In number 9, we only need to multiply by what's under the radical to both the numerator and the denominator. So if I multiply the numerator by rad 3 and the denominator by rad 3, in the numerator I can multiply what's under the radicals, so I'll end up with rad 18. And in the denominator, I'll have 2 times rad 3, which is just 3. In the numerator, there are perfect square factors in 18, so I need to simplify that. So I can break that down into rad 9 and rad 2, and the denominator becomes 6. Rad 9 is 3, keeping the rad 2 over 6, and when I simplify, I end up with rad 2 over 2.